Welcome friends to SSC CGL Tier 2 level quick algebra problem solving. This is Atanu Chaudhary of SureSolve. This time in the first part we will solve the first 5 questions of SSC CGL Tier 2 solution set 3 on Algebra 3 from suresolve.com. Let's solve the first problem. Question 1 is, if 4y minus 3x equal to 13 and xy equal to 14, then 64y cube minus 27x cube is option A 8479, option B 8400, option C 8740 and option D 8749. Identify that in the subtractive target expression, cube terms are cube of 4y and cube of 3x, when the given expression also is subtractive 4y minus 3x. That makes your job simple. You have to evaluate just a subtractive sum of cubes. Assume p equal to 4y and q equal to 3x for convenience. This makes the given expression as p minus q equal to 13. And you have to evaluate p cube minus q cube. You will need the value of pq in the two-factor expansion of p cube minus q cube. So evaluate it right now as pq equal to 12xy equal to 168. Now use the modified two-factor form of p cube minus q cube to get its value directly as p cube minus q cube equal to p minus q multiplied by p minus q whole square plus 3pq equal to 13 multiplied by 13 square plus 3 into 168. Equal to 13 multiplied by 169 plus 504 equal to 13 multiplied by 673 equal to 8749. Answer is option D 8749. Carry out the calculations mentally if you can. That is not a difficult job. And if you do it by hand, it won't also take much time. The second problem now. Question 2 is, if x equal to 0.09 whole square, y equal to 1 by 0.09 whole square, and z equal to 1 minus 0.09 whole square minus 1, then which of the following relations is true? Option A is y less than x and x equal to z. Option B, y less than z less than x. Option C, z less than x less than y. And option D, x less than y and x equal to z. As 0.09 is less than 1, inverse of its square will be much larger than its square, so that y greater than x. Answer will then be one of the options C or D. Assuming p equal to 0.09 for convenience, you get x equal to p square and z equal to 1 minus p whole square minus 1 equal to p square minus 2p. As p equal to 0.09, p square minus 2p will be negative. So, z less than x. You don't have to do any calculations. From abstracted algebraic relations and value of the variable, you can draw your conclusion with confidence. Correct relation between x, y and z is then z less than x less than y. Answer is option C, z less than x less than y. With this approach, the problem can easily be solved in mind. Let's solve the third problem. Question 3 is, minimum value of x to the power 4 plus 1 by x to the power 4 plus 1 minus 3 is option A 0, option B minus 1, option C minus 2 and option D minus 3. Identify that the target expression can easily be imagined as a sum of inverses with abstracted x to the power 4 plus 1 taken as a dummy variable p. As we know that the minimum value of sum of inverses p plus 1 by p for positive p is 2, finding the desired minimum value would be just one step more. Add 1 to the first term x to the power 4 and subtract compensating 1 to get the changed target expression as x to the power 4 plus 1 plus 1 by x to the power 4 plus 1 minus 4. equal to p plus 1 by p minus 4 with p equal to x to the power 4 plus 1. As x to the power 4 for real x is positive, p is positive, and minimum value of p plus 1 by p is 2. So the minimum value of the direct expression is 2 minus 4 equal to minus 2. Answer is option C, minus 2. If you are able to discover the pattern of sum of inverses and know the minimum of sum of inverses concept, this problem should take very little time. Otherwise, it's a difficult problem. Let's see the next problem. Question 4 is, if p by 3 equal to q by 2, then the value of 2p plus 3q by 3p minus 2q is option A 1, option B 12 by 5, option C 5 by 12, and option D 12 by 7. The given expression easily gives you the value of the ratio of the two variables as p by q equal to 3 by 2. Let's now turn our attention to the direct expression. The speciality of the direct expression is both the numerator and the denominator are balanced individually and between each other in the powers of p and q. Power of p and q are same in each expression, as well as this power is same for both the expressions. This special pattern enables you to divide both the numerator and the denominator by q and convert the whole expression fully in terms of p by q as 2 times p by q plus 3 divided by 3 times p by q minus 2. Substitute the value of p by q equal to 3 by 2 and get the value of direct expression in one step as 6 by 5 by 2 equal to 12 by 5. Answer is option B, 12 by 5. It's easy and quick. Let's solve the last question. Question 5 is, if a minus 4 whole square plus b minus 9 whole square plus c minus 3 whole square equal to 0, then the value of root over a plus b plus c is option A plus minus 4, option B 4, option C minus 4, and option D plus minus 2. The sum of the three square terms in the given expression to be 0 for real a, b, and c, each of the square terms individually must be 0. This is so because in square form, each of the terms will be positive so that the sum cannot be 0 unless each is 0. We call this as principle of zero sum of square terms. Thus, a minus 4 equal to 0 or a equal to 4, b minus 9 equal to 0 or b equal to 9, and c minus 3 equal to 0 or c equal to 3. And the direct expression is square root of a plus b plus c equal to square root of 16 equal to 4. Answer is option B, 4. Mathematically, the square root function returns a positive output. It cannot be negative, and so root over 16 cannot be equal to minus 4. In the square of plus minus 4 equal to 16, the negative sign in the input is converted to a positive sign in the output because of double multiplication of the factor minus 1. One can still question what will be the square root expression when the output result is minus 4. It will simply be minus 4 equal to minus root over 16. If you are not very clear about the square root concept, there is a chance of mistakenly selecting option A plus minus 4 as the answer. Okay, here we end the first part. To read the detailed solutions, refer to the corresponding article in our website suresolve.com. Link is given in the description of this video. And please don't forget to subscribe to our channel for latest uploads. Thanks for watching.